then I cannot join it with anything in finances. And it's bad. Because I would like the grant ID, the grant one, the grant had these phone numbers. One of these phone numbers is the phone number of the manager of that grant. And basically the color is telling you which one. So I would like this G1 to be able to join with this first line. I like the G2 to be able to join it with the second line. If I put null, I cannot join. If I put always the same number, I will join even the first with the second, which I don't want that. Or if I put random value, yeah, it's worse. Okay? So there is another area of research which is called data exchange, which has to do with what kind of values we can put there in order for this instance to have some specific properties. Okay, I will not enter into this discussion for the moment, but just to know that there is also a third phase. So we have schema matching, mapping generation, and the data exchange case. So all these three are. So we had developed one tool that we had developed is it's called the Clio system, which what you are doing is actually generating the mappings. You draw the lines. Here comes the question that you made about who generates the lines. So the lines can be generated automatically by the schema matching tools that the schema matching community has developed, or it can be drawn by hand. So in the specific tool, you can do it by hand. You take the mouse and you say, this corresponds this to this. And once you do it, then the system generates all the possible interpretations. Every column here is a possible mapping. And then the user has to decide this mapping should be considered, this should not be considered. So the system just generates all the possible interpretations. The values, here if you see the financial ID that we have here, you see some function that is called SK74. These are Skolem functions. If you know what are the Skolem functions, they are used for the data exchange case, because this system also has a data exchange module inside. So this was just to give you an idea. There are other tools, other schema mapping tools. This is another, the SPICY system, which from the University of Basilicata. This is very similar to Clio. It's doing more or less the same things, more or less. But Heptox is another from the University of British Columbia. And what you see here are the commercial tools. And here starts the fun. Because if you thought that until now was a little bit clear, the commercial tools, what they have done, so you draw in some cases you draw the lines. No, sorry, this one. You draw the lines and the system generates a graphical interface. Here you draw some lines, or you put also in the lines some boxes, and these boxes are the functions that you asked before, that when you are doing conversion from dollars to euros or things like this, or you can even have more complex functions, and the system generates here an X query. This one, you see how more complicated it is. You can basically build any building blocks here, any transformation here, and the system generates, it's not visible here, the output is an XSLT, for those of you who know XSLT. Okay? And so this tool, basically it's an interface for generating XSLT transformation scripts. It doesn't have, usually these tools don't have much of intelligence. They expect that the user doing the full specification, so they don't do any reasoning. But yeah, these are also schema mapping tools. Okay? So these are the schema mapping tools, and now let's see how we can create a benchmark for this kind of tools. Now, what are the issues for generating a benchmark? Now, first question, what is the input to the system? If you understood what is happening here, usually if we are talking about the databases, an input to test, if we want to create a test case, the input is an SQL query, right? We tell to the database, here is an SQL query, execute it. For a schema mapping system, what do we give? Do we give nothing, just the source schema and the target schema? But this means that the schema mapping tool has to do also the matching. And then there will be different cases about the matching, and then we will argue whether the matching was correct or not. So let's assume that we give the matching. How do we give the matching? Just the arrows. The arrows, as we said, they are not fully specifying the transformation. So how do you tell to the system what is the transformation? Because when we were talking with the people from the schema mapping tools, and we told them, and I will show you some examples, we draw these lines. Your system generates this query, while the other system generates this. So yes, according to our system, this is correct. That was the response. I mean, the reasoning, the logic that they have put inside, they said that is correct. And they were right, because there is no formal specification of what these lines mean. That's the problem. Okay? So what is the input, what do we give, and what is the output? What do we expect the system to generate? Do we expect the research prototypes? They say we generate the mappings. So meaning we generate these logical expressions. Others, they say we do also the data exchange. So we generate the target instance. Others are saying, no, we will generate only the transformation query, which is the logical, first order logic expression plus the data exchange thing, two combined. Nothing was clear, okay? This lack of semantics was the big challenge there. So we have, when we were creating, we said, okay, for sure we put the source schema, we put the target schema. Maybe we give also an instance of the first schema. And then somehow we have to tell to the system, yeah, what we want to do, okay? Now, in these cases, what we decided to do, before I tell you how we decided to do it, here are some examples. So this is, I'm not inventing this, these are examples taken from the commercial systems. So this is the simplest scenario you can imagine. We are copying a table with two columns from one database to another. Okay? So I load the system and I say, look, what you call here name is the attribute title of organization in the second database. What you call here location is address of organization in this database. And here is an instance. 2 entries, 2 tuples in the first database. Okay? So we run this in one, what do you think this is going to generate? Right? 2 tuples, I guess this is the most natural thing. Well, if you put it in one of the systems, which basically at that moment it costed around 3,000 to buy, this is what it's going to generate for you. Okay? Now, how do you argue that this is wrong? I mean, I understand that you feel that this is unnatural, okay? But they are not violating something. If you ask them why this is wrong and you argue with them why this is wrong, they will tell you, yes, this is wrong, because if you want to do what you are expecting to do, to have one entry for IBM and one entry for Microsoft, then in that specific system, you had to put an extra line between company and organization. That's how they designed the system, right? Again, lack of formal semantics. Another system just takes only the first one. Anything else is rejected. Okay? Yeah. This is how they told us that this way. If you put here the line, then this is correct. Okay, so we said, okay, how do we tell to the system what we want to transfer? How do I tell to the system, as a scenario, I want you to copy this table from here to here? First case, I can do it with natural language. So I can write a text that says, I am expecting that you copy all the data from the organization to this second table in the second database. But okay, this is simple, but if we are talking about, the problems with natural language is that you don't have formal semantics. People express the same thing with different words. So we don't like it. As researchers, we don't like natural languages because it has ambiguous semantics. So we cannot easily implement it into the systems. I mean, it's very cool and nice as users, okay, and very useful, but yeah, you cannot easily implement it into a system. On the other hand, you can do as full specific, something very formal. Okay, so and the most formal that I can imagine is a query. Okay, take SQL for instance. Formal semantics, if I give you an SQL query, there are no different interpretations. Everybody understands what an SQL query, a given SQL query should do. Okay? But now imagine that I have a system that I say to the system, here is an SQL query that is telling you what you want to do. Please generate for me the SQL query. Basically, you are giving the system what the system is supposed to generate. Right? So that's the other extreme. Many of them said to generate a graphical interface. They have a graphical interface with constructs that you build, and you build the query. But then it's a graphical interface for building queries. So then there was the other idea. Let's give to the system the matchings, just the black arrows. But then there are so many black arrows. We had the direct one-to-one that you saw before, but there are also more the many-to-one. There are also these arrows that have function, as you mentioned. So there are many, many different cases. So again, it's ambiguous, even the arrows. Okay, then it's the typical question: what are the situations that we have to consider? How do we compare the mapping tools? What do we test? In databases, it's the time, how fast the database answers the query. Here, what do we test? If you do it, I can guarantee you that in one way or another, all the system at some point they can do it. So they're all equal. They can all generate what you are expecting. You can test the time, but time for what? We're talking about schema design here. The time is not such an issue. If you want,
Is it maybe just the usability question?
Good question. So this is another possibility, right? You can measure how hard it is to generate this, which is a very good point, because at the end of the day, this is why we built the mapping system, to help the user. But then the problem is that it comes a lot. We did some testing with the systems, and depends on how well they designed the GUI. So if the graphical interface is good, but then we didn't want to test the graphical interface, the graphical feature, because the graphical features are changing continuously. But this was another point. So we test the effort, we test the expressiveness, we send the time. These are all issues to consider. Okay. So what we decided at the end, we built a system which we called ST benchmark. ST means source to target benchmark. Okay, and one approach that we decided to follow is what's called micro benchmark. I will tell you what this is. So what we did is that we said, okay, first of all, we have to decide what are the scenarios, what are the interesting cases to consider. So we looked at the literature. We started reading papers. And every example that we were finding in the papers, we were trying to collect it. So we made a whole collection of possible cases. And in these cases, so we looked also surveys, et cetera, and what we tried to do is to identify in every integration scenario, in every data exchange scenario that we could see, what were the primitive operators that were taking place. So one primitive operator is, for instance, copying a table, as I told you before. Usually you don't find it that much. I mean, the real world cases are way more complex. But what we were trying to do is to identify the primitive operators that you are doing in this kind of cases. And by doing this, we came up with a list of, I don't remember, I think there are 17 different cases. Okay? This is copying. We are copying a table. This is we are generating an attribute with a specific value, fixed value. Horizontal partition. We're taking a table and we put some of the tuples in one table and some of the tuples in another. Okay, this is the list. Now for each one, for each such scenario, what we did, since we couldn't decide how exactly we should give the user information of what we want, so we did both. So we said we have a textual description, which we describe exactly what we want to achieve. And we also provide some query that is telling you what you want to do. So this is what you see here is the copy. You are copying all the data from here to here. Okay? And this is the information that we're giving. So for every schema mapping tool, we are saying, please, let's see if you can do this. Yes?
Would the ideal tool just take the textual description and do what you want it to do?
Yeah, there is no such tool, but yes, that would be perfect. But the textual is the problem, that the ambiguity. I mean, how well, it depends how well you express it, right?
You need some domain expertise to resolve some of the issues.
Absolutely.
And that goes into the textual description.
Yeah.
So if a tool, for instance, lets you generate the textual description step by step as it encounters the difficulties, that would also be possible.
Yeah. But then you develop a formal language. And this, Okay, so we have this kind of test cases, and now what we wanted is, remember that I said we need to stress test the system. We want to test the system in extreme situations. So what we did is that we said, okay, we take these primitive transformations, copying, editing, splitting, and we want to expand it, to stress them, stretch them. Okay? So how do you stretch a primitive transformation? You identify some parameters and you change these parameters. So the parameters, for instance, could be the number of sub-elements. So meaning if you have a table, how many attributes it has. Nesting depth. If you have nestings, how deep is this nesting? If you have joins, how long are these joins? Do you join 2 tables, 3 tables, 4 tables? And if you join the tables, on the join, how many attributes do you use? Do you use only 1 attribute, 2 attributes, or 3 attributes? And how do you join them? Do you join them as a chain, or one after the other, or you are joining them as a star? Okay? And then we have functions, etc., etc. So these are all parameters. So having identified these parameters, what we do is we take any primitive transformation and we stretch it by deciding random values for these parameters. So this is the example of the nesting, and we say, okay, if we take the parameter that says the nesting depth, in this case it was 1, because you see that have the authors nested within reference. We say just a random value for depth. Let's make it 3. So we have a nesting depth 3. Okay? Now you have a little bit more complex. I mean, it's basically, again, a primitive scenario, but pushed a little bit to the limit. Or when you are doing the horizontal partitioning, okay, here we split the tuples of a table into 2. Let's make it 3, or let's make it 4, let's make it 5. Okay? So this way we are generating scenarios. Okay? They're both, this scenario, what you see is still a split, but split in 3, while the original one was in 2. And then we said, okay, we have all these cases, primitive cases that we stretched, and then we concatenate them to create the whole scenario. So now you have a schema, a whole schema that has, this is the source schema, this is the target schema, and you can identify the different parts. This is a copying, this is a, here I have, I think, a better example. Here. So you see, so here we have a complex schema, which, not a complex schema, a schema that has the first part is horizontally partitioned in this. This second part is just copied, and this one is unnested. Okay? Yeah.
So if you test, do you still need to draw them in this graphical interface?
Yeah. You do exactly the same. Yeah. So we know, but what happens is that we know that this is a copy, this is an unnesting, this is a horizontal partition. So I'm telling you that you have a mapping tool. This is what I want you to do. I want you to do a horizontal partition here, a copy, and an unnesting. Can you do it? Okay. So to
how well I know the system?
Yes. But, yeah. But at the end, it's a user that is using the schema mapping tool. Yeah. It's not like the database that you send the query and you wait for the database to respond. Yeah. But of course, as you can say, this is not very natural, right? Because how many systems that you know, that the real cases that you say, one is the partition, one is copy, one is nested. So usually real world scenarios are way more complex. You have a transformation that has a lot of things inside. It has a copy and merging, etc., etc. So we said, okay, let's create also a complex scenario. How do we create a complex scenario? Take an original schema and start applying to these transformations. But we keep track of the kind of transformations we are applying. So first of all, for instance, we do an unnesting. Here you see that the S3, the A10 and A11 were unnested and they went to the first level. Then we apply removal. We just delete some attributes. Then we apply duplication. So you see the A4, A7 was also duplicated in another table. Then we apply migration, means you move one attribute to some other, from one table to another. then you can apply, keep going. We add extra attributes, okay? One after the other. But I repeat, I keep track of how many changes I do. And then I have the final schema. Now, here is my source schema, the one I started. Here is my target, the way I did it. And the transformation query is the sequence of transformation that I did. So now I have my complex scenario. I give it to the system and I say, let's see if you can make it. Yeah.
But is this transformation unique? Can you, for instance, define an edit distance on this?
Yeah, there are many different transformations that takes you from here to here. That's also another challenge. So what I wanted is that, yeah, here is a transformation, and this comes to another challenge that was there. How do we measure the success of the system? If you have a different way to achieve this schema, are you wrong or not? And you are claiming not. I mean, you are achieving the same schema, which is a good point. Okay? So in order to measure the success of the system, exactly for this reason, we said, okay, we are not going to measure whether you are actually achieved exactly the same transformation, but whether the instance data that you can achieve with your transformation and with my transformation is the same. So we don't look at the queries that are doing the transformation, but we are looking at the results of the transformation. Yeah. Okay. Right? So this was basically how we came up with the benchmark for schema mapping systems. This idea of micro benchmarks, of using micro benchmarks, taking small transformations and applying them. Test the system and create more complex situations. We have applied it not only for schema mapping, we started with schema mapping, but we have applied also in other areas. So for instance, we have done this in entity matching, where entity matching is the case where you are looking not at the schema, but you are looking at the instances, and you are trying to find out whether structures that have different structures represent the same real world entity. And the way you do it, we had what are the primitive transformations are basically noise, misspellings, synonyms, abbreviations, etc., that you can inject into the system, and then test the system whether the system can identify